Past paper question 2. This one is worth 5 marks, and that's the biggest amount of marks that they can ask you in a question in a National 5 paper. Katie and Mona are looking up at a hot air balloon. In the diagram below, K, M and B represent the positions of Katie, Mona and the balloon respectively. And it says that from Katie, the angle of elevation of Katie looking from ground level up to the balloon is 52 degrees. For Mona doing the same thing, she only has to look up 34 degrees, and the distance between the two of them is 350 metres. And what I want to actually do here is I want to find the height of the balloon above the ground. So really it wants me to work out this vertical height here. We'll call it h. Now this is a bit unusual compared to the questions that we've been doing already, because the questions we've been doing has just been finding related sides and related angles. This one is getting us to work out a perpendicular height within the triangle. But the process that we go through is no different. In order to find out that height, what we're going to have to do is get a bit more information about the triangle. Right now we only know one side, and we know two angles. So perhaps let's find out another side and then see what we can do about that. With regards to the two angles, remember, no matter what situation you're in, always try and make sure that you use the fact that you've got two angles and you can find the third angle straight away. You might need it, you might not. So 52 and 34, that means this angle up here would have to be 94 degrees. So let's label our triangle. So this will be side K, this will be side B, and this will be side M. So this is going to let me think about, I think I'm going to have to use the sine rule here, because I don't have two sides and the included angle to allow the cosine rule to work. It has to be the sine rule. So that would give me that A over sine A is equal to B over sine B is equal to C over sine C. So let's rewrite that in terms of B, M and K. So that'll be B over sine B is equal to K over sine K is equal to M over sine M. So then let's tick off what we know. Well, we know all three angles, and we also know the size of side B. Now, in order to find out eventually the height, I'm going to find out one of the other sides. This is where the exam part of it being an exam question really comes in, because it's up to your choice. I could find out the size of side K or the size of side M. It doesn't matter which one I use here. Let's just find out the size of side K. So forget that question there, that fraction I should say. So we're going to work with B over sine B is equal to K over sine K. So let's put in some values then. So that's going to be 350 over sine 94, and I've got that because I found the third angle, is equal to K over sine 52. So cross multiply, so that will be K times sine 94 is equal to 350 times sine 52. So K is going to be 350 times sine 52, all divided by sine 94. So then all we do is just go to a calculator and then process this. So 350 multiplied by sine 52 over sine 94, which will give me 276.48 meters. and that's to 2 decimal places. So 276.48, that's now going to be the size of this side here. How does that help me find out the size of the height? Well, since height is perpendicular to the ground, you can always assume that a height always meets the ground at right angles. So I can create a brand new triangle out of this. And that's where it didn't matter if I found out side K or side M, because if I found out side M, I would just use this triangle over here. So I'm now going to use the triangle from B down to the ground and then along to M. So let me just draw that out then. So this angle here is 34 degrees. This is 276.48. And I want to work out this side here. We'll just call it H. Okay? So really what we can now do is two things. We can either use the rules we've already been using, the sine rule, the cosine rule, etc. Or it's a right angle triangle. It's back to very, very simple, straightforward trig. Okay? So label our sides. This would, if that's the angle we're looking at, this would be the opposite side. This would be the adjacent side. This would be the hypotenuse side. So that then allows us to write out SOHCAHTOA. And then tick off what we know. Well, we know the angle, so tick off the S, the C, and the T. We know the hypotenuse side, so tick off your H's. And we're asked to find out the opposite side. So put a line underneath the O's. So two ticks in a line, we're going to use sine. And if you were doing this not using SOHCAHTOA, it would be the sine rule you would use. Okay, SOHCAHTOA comes from the sine rule. So let's use this. So that's going to be sine x is equal to opposite over hypotenuse. So that's going to be sine 34 is equal to h over 276.48. Cross multiply. So h is going to be sine 34 multiplied by 276.48. So then just go to your calculator, work it out, and you get 154.605.654. So finish off the question, so we can say therefore the height is equal to 154.61 meters, and that's to 2 decimal places. And that is really the trickiest that an exam question can be involving trigonometry at National 5 level.